So let's talk about Earth's moon. We're going to talk about the moon, even though it's not a planet, because it helps us understand everything else. It's something that's accessible, it's something close, it's something we can measure, and we can use it to figure out what's going on with some of the other planets. The moon's surface has impact craters. When the telescope was first pointed at the moon and they saw these, nobody knew what they were. It was argued that some of the things they could see, like this little thing right in the middle of this crater, were maybe volcanoes. That's why I messed that up. And over here, there were features that they just didn't understand. It was argued that they were volcanoes on the moon. It wasn't until the United States developed an atomic bomb and started doing atomic tests out in the desert, which were so classified nobody was even allowed to go see the craters, that a scientist, I gotta tell you his story, but a scientist who got permission to go study those craters, recognized features that you can see in telescopes on the moon were also in the craters from atomic bomb tests out in the American desert. So he was the first one to provide evidence that they were impact craters. Okay, his name was, I think his last name was Shoemaker, and when he was a kid, he wanted to go into outer space. He wanted to go to the moon. He wanted to be an astronaut. This was like in the 1930s or 40s when this just wasn't happening. He determined as a young kid that in order to go to the moon, they would need scientists. They'd need people to study the rocks. So he became a geologist just so that he could study rocks on the moon, because he figured that was the type of person they would need. Nobody expected them to send Air Force fighter pilots and Vietnam War ace pilots and test pilots. They did send one geologist to the moon on the last mission. His name is Jack Schmitt, and he was one of the last ones on the moon. But they had to train the astronauts a lot of geology to be able to do it. So we do know that they are impact craters. As a matter of fact, we've been able to see a couple form. Sometimes there'll be a flash of light, and noticed on the moon they point a telescope and there's a new crater there. The craters allow us to help determine the ages. I mentioned this when we talked about Mercury. There's a crater right here inside of a crater. By the way, I'm not sure which craters I'm looking at, but I'm going to estimate this one is probably a few hundred miles across. So this one down here is probably bigger than the city of Atlanta. Yeah. The biggest telescopes on Earth can see that there's a crater. The smallest ones they can see are about a quarter mile or so, about the size of a stadium. So that's about the best we can see from Earth, is recognizing there's something there that's about the size of a stadium. There are two parts to the moon's surface. There are the highlands, and I'll bet you can guess the other. And these are the most heavily cratered parts of the moon. If there are lots and lots of craters, then that means that there's been no changes since the heavy bombardment billions of years ago. So it's a very, very old surface. The rock has been ground down to this dust that's called regolith. This is evidence that there's been impacts all over here. The impacts are so great that these rings that you see around the crater walls, they're sometimes as much as 2 miles high. When we saw the meteor crater out in New Mexico, we were driving through the desert, and it wasn't until we got closer that you could see a very clear ridge sticking up out of the desert. And it was, I don't know, I'm not real good with altitude, but it was less than 1,000 feet. It was probably about 700, 600 feet high. That's like, what, a tenth of a mile or so, less than a quarter mile. On the moon, some of those ridges are 2 miles high. So those are some pretty big impacts to do something like that. The lowlands, or Maria, which is Latin for sea, they thought those were oceans on the moon. Matter of fact, right here is where Apollo 11 landed in what's called Tranquilis. Oh, shoot. I'm trying to remember the Latin here, sorry. The Latin is Sea of Tranquility. So when Apollo 11 landed, they said Sea of Tranquility here. The Eagle has landed. That was an actual military term where the Eagle was their ship that they named, and then they landed at a base and gave it a name, which is typically what the military does. So when they announced Sea of Tranquility here, everybody on the ground was like, what? What did he say that for? And then they all, had to be told that these guys are military guys, so they just named the place they landed. The lowlands are actually filled in lava flows. They're smoother, there's fewer craters, which means they're much newer than the highlands. Yeah, so there was lava flowing, and now you're going, wait, they were volcanoes. No, the center of the moon used to be liquid like Earth, and it went through periods where the crust would crack and fill in, and the stuff that we're seeing today simply happened after the heavy bombardment. So when I say this is new, it's newer than like 3.5 billion years old or something like that. Which is older? The highlands. And you should know that because they are heavily cratered. By the way, check out this picture right here. This is on the southern part of the moon. And so when you're looking at it, when you look in a telescope, this is actually an upside down image, but when you're looking at it with the naked eye or binoculars, you'll see this on the bottom, and this crater is called Tycho, named after Tycho Brahe. We talked about him. He was the drunk party animal that made the measurements and got in a sword fight over who was the better mathematician and lost his nose. And you can see these rays, that's what they're called, traveling upwards of 1,000 miles of just scattering rock and debris in all directions. The Apollo missions were the only ones to go to the moon, and we basically went and proved our might that, hey, we can put rockets and we can put men on the moon. We can put rockets in Moscow if we want to with nuclear weapons. So it was basically a show of force, the race to the moon. And there wasn't a whole lot of science out of it, but there's still a lot. There's still a lot that goes on from those missions. It looks like China might be the first ones back to the moon. NASA has announced, I want to say 2026-ish, and I think China's announced 2024. But we will probably see people going back to the moon, like soon, within the next decade. Maybe, we'll see. What's interesting is in all of the missions, they brought back about 800 pounds of rock and soil. They sealed them in containers on the moon so they could preserve the specimens and bring them back to Earth. Those are kept in Houston, Texas, in a very special lab where the containers that supposedly have no atmosphere in them because of the vacuum of the moon, they actually think that because the rock is and the soil is very, very rough because there's no weathering on the moon, so it's like stepping on glass or something like that. If you've ever gone to a volcano, the rock is very sharp. They think that actually ruined the seals on the canisters, so they're probably not pristine condition, but they're the best they can do. And they've got the samples basically in vacuum chamber, and so far they have opened less than half of those canisters, and they're considered American property. They belong to us because they're classified as national treasure. What's really cool about that classification is, well, the military and police have got the capability to give shoot-to-kill orders in order to protect them. If you go to a museum, they are behind bulletproof, bomb-proof glass. When they're transported, they are heavily guarded. People are in federal prison right now for stealing moon samples. And I really wish, I'm so sorry, I really wish that we were not in a pandemic, because I'm certified to get samples from NASA and bring them to the classroom for 2 weeks. They're specially designed to be sealed up, but in a way that you can handle and take pictures of right here in the classroom, real moon rocks. But that's just going to have to wait. So if you are, if the pandemic eases up and I can get them in the late spring, I'll do it just because. But if you're not a senior, stop by and ask me about it next year, and I might know when we'll get those. But one thing that they found is that all of the moon rocks are igneous rocks, which means that they used to be liquid, basically frozen lava. So that indicates that the moon was once liquid, just like Earth, or what's called breccia. Breccia is broken, fragmented rock that's been cemented together, if you will. So that would have occurred from meteor strikes, making fragments, and then another meteor comes along and hits those fragments and fuses them together. So you see this all over the place on the moon. It has just been pulverized to pieces. This led to some interesting things. Vesicles, these gas bubbles. They can actually analyze the gases that were trapped in the rocks and figure out some of the history of the moon and what type of asteroids hit it and that sort of thing. But the fact that the Earth and the moon were both liquid and are pretty much the same age means that they didn't start out separately. They formed together. Mars has 2 moons. One of them is called Phoebe, and Phoebe, and it looks like a potato. Literally, it's a captured asteroid. We have discovered through this that the moon is not some captured object. It didn't get caught up in Earth's gravity, but it actually formed along with the moon. There was a really insane, weird hypothesis 100 years ago, 75 years ago, and when that said that a Mars-sized object crashed into Earth and formed the Earth and the moon, and everybody thought that was nuts, until NASA brought back the moon rocks and we realized actually that has to be the way it happened. It's called the Large Impact Theory. It's based on the fact that these rocks came from a molten state, but also that there's very, very little iron on the moon. As these things would have collided, all the iron, or most of the iron, would have sunk to the core of the combined object. And then after the collision, this picture shows the collision, but after the collision, these things spinning around would have flung off a piece like Play-Doh or something up in the air and actually cooled off and formed our moon. That's it. Have a good day.
There's only one thing, Ralph, that's missing from my Disneyland. Only one thing. The world of tomorrow. I have nothing from the world of tomorrow.
You want the world of tomorrow?